So this is a blockbuster of an assessment of global climate change by the World Meteorological Organization. It leaves no question whatsoever that we are in a most dire planetary climate emergency, that the situation is quite awful. The WMO confirms that everything important with regards to climate change and indicators are accelerating. It confirms that global warming is accelerating.
Hello, and welcome to another edition of the Climate Emergency Forum. I'm Herb Simmons, author of A Climate Vocabulary of the Future, and I'll be your host today. Our focus of today's program is a topic of immense importance, the state of the global climate. We'll be looking specifically at the annual report issued just in the last week or so by the World Meteorological Organization. It contains grim news about virtually every aspect of our planetary system, our atmosphere, our cryosphere, and most critically, our oceans. The headline this year perhaps focuses on a metric that until now has not been in wide use. It's called the Earth's energy imbalance. This is the difference between the heat that comes in from the sun and the heat that radiates back out into space. In the stable world we lived in for centuries, that balance was roughly equal. Today, it is dangerously out of alignment. To put it into a stark perspective, according to the latest WMO data that I've sort of massaged a little bit, our planet is now trapping heat at a rate equivalent to, listen to this, 12 Hiroshima-sized atom bombs detonating every single second. This staggering imbalance is driven by three accelerating forces that we'll be talking about today. 5 of those 12 bombs per second come from our record-breaking greenhouse gas emissions. And these are rough figures, of course. 4 bombs per second are the sort of penalty that we're paying for cleaning our air by removing sulfate pollution from ships and industry, as if we've essentially ripped a protective sunshade off the planet. And the final 3 bombs per second are now being contributed by the planet's own failing feedbacks. As ice melts and clouds thin, the Earth becomes darker and more absorbent. Joining us today will be Dr. Peter Carter and Paul Beckwith. We invite you to stay until the end of the program for the Climate 3, where I'll break down the 3 of the biggest climate stories of the past week in 1 minute each. And as always, if you like this work, please like the video, subscribe to our channel, and visit us at theclimateemergencyforum.org. Your donations help keep this program, one of the few programs dedicated to the climate emergency, on the air. So let's start with you, Peter. I know you've recently done a program on this report. You're familiar with it. What do our viewers most need to know?
Thanks, Evan. That was a really brilliant way of communicating the rapid increase in Earth's energy imbalance. Of course, Earth's energy imbalance has been the focus of James Hansen's communication for decades. But I don't think people really ever cottoned on to how serious Earth's energy imbalance is until quite recently. And the WMO, this is the first time that they've included it in their state of the climate. And I guess my comment will be about time. So this is a blockbuster of an assessment of global climate change by the World Meteorological Organization. It leaves no question whatsoever that we are in a most dire planetary climate emergency, that the situation is quite awful. The WMO confirms that everything important with regards to climate change and indicators are accelerating. It confirms that global warming is accelerating. The last 11 years were the hottest 11 years on record, and the last 3 years were the hottest years. Of course, the data is very clear that global warming is not only accelerating on the long term, it's accelerating on the very short term of just the past few years. And that really, really is dynamite. It also states, quote, that Earth energy imbalance is not just increasing, it is accelerating. So, with our planet, as Herb has just explained so well and so quickly, as the planet is storing up, trapping more and more and more greenhouse gases in the atmosphere at an accelerating rate, it's absolutely insane that nothing is being done about it. I mean, it's really insane that we don't have a massive pressure from everyone in the world forcing their governments to do something about this. But we, of course, have the opposite. We have our government subsidizing the fossil fuel industry in increasing amounts. The last assessment by the IMF was $7.6 trillion a year. This is criminally evil because this is planetary destruction, wrecking the future of humanity. So, as I say, this report is really, really important. Now, they give a number, and actually, they put up a column graph, which makes it really rather clear that Earth energy imbalance hasn't simply doubled over the past couple or 3 decades or so. It's worse than that. It's tripled. Because if you take the last assessment by Loeb, Loeb, there is an absolutely incredible increase in Earth energy imbalance. Now, that's actually nothing new. That was reported by a joint press release by NOAA and NASA some years ago, that there was a very similar extraordinary rate of increase happening on Earth's energy imbalance. And that report was absolutely solid because they had measured it from serious NASA satellites, but they'd also confirmed it from the NOAA ocean buoy calculation. So there's no question about it. So we've known for 15 years that Earth energy imbalance is accelerating. So yeah, I thank WMO for at last bringing that to our attention.
Thank you, Peter. I think it's fair to say, and I suspect that Paul and you will address this later on, that something like 90% of that heat is not in the atmosphere, even though we feel it in the atmosphere through hotter days and hotter nights, but is going directly into the ocean with all kinds of devastating, but largely unknown to most of us, impacts so far because of the vastness of the oceans. But thanks for that very sobering initial perspective. And I'm happy as always to turn it over to Paul Beckwith. Paul, I know you've also looked closely at this report and talked about it on your program. Give us your perspective.
Thanks, Herb, and thank you, Peter. As Peter has already mentioned, I think it's very interesting that the WMO is now looking at Earth energy imbalance. A lot of so-called mainstream science has not really looked at that question, and James Hansen talked about it, I believe, in his first book over a decade ago, and many of his update reports and so on are talking all about it. And we're obviously seeing an acceleration in global warming in terms of temperature rises. We were already above 1.5 degrees for 3 years on top of a strong El Nino event that happened. And it looks like towards the end of this year, we're going to have another El Nino or warming event in the Pacific, which will probably drive us over 1.7, something like that, degrees Celsius if it occurs. If it doesn't occur, then that heat is still being stored in the oceans and it'll come out in a subsequent year. So there is a lot of importance, of course, to the oceans. The oceans have buffered atmospheric temperatures for a long time. What is that 90% of heat going into the oceans? It's really, global warming is really ocean warming. And then with a warmer ocean, there's more evaporation, so more water vapor carried up into the atmosphere. That latent heat is released in storms, so there's more intense storms. And the direction and location of those storms is driven a lot by what the jet streams are doing. But the report, it very clearly shows that most of the heating of the oceans is now being concentrated in the upper 700 meters, the surface down to 700 meters, even more so down to 300 meters. And there's less heat going into the deep oceans because the mixing of the oceans is declining because of the increased layering of the water or stratification. Of course, warm water is lighter, lower density than cold water, and salty water is heavier, more dense than fresh waters. So as the oceans warm, the water is lighter and it's harder to get it to mix to depth. So we're seeing this massive change around the oceans in stratification. So we're seeing more and more marine heat waves. And when we have these marine heat waves, and when you have winds over the oceans, then you get more evaporation, and that heat can then go up into the atmosphere. So directly, the atmosphere is only getting, 1 or 2% of the heat. I've seen it quoted as 1% some places, 2% other places. But, the rise in atmospheric temperatures, that's just, a tiny, tiny fraction of the overall heating of the planet. And, the Earth energy imbalance, as you said, Herb, it's, you look at the energy coming in from the sun, and you look at the outgoing energy, and the difference is the Earth energy imbalance. And the amount coming in to the Earth system is doesn't change significantly. It changes a bit with sunspot activity, orientation of the Earth, etc. But what's changed is the outgoing energy. Because the Earth is getting darker, the albedo is darkening with loss of sea ice and fewer clouds over the ocean, fewer aerosols to seed those clouds. Those things are all feedbacks that are making the albedo or reflectivity of the Earth lower, so therefore less light is being reflected back up into space. More energy is being absorbed into the system, greatly accelerating the heating. And when you get these, the stratification of the ocean, less heat is actually going down from the surface to the deeper depths to be stored. So all of these factors are combining to accelerate global warming. And Hansen talks about how the planet was warming about zero point 0.2 degrees Celsius per decade up until about 2000. Since then, it's been about double, zero point 0.4, 0.43 even degrees Celsius per decade. But we've got a curve that is increasing exponentially upwards. So if you try to take a linear fit to any part of that curve, then it's only valid for a short period of time, and then you get an acceleration. So that's what they're seeing. The most important point in this report is that it's acknowledging the importance of the Earth energy imbalance, and I think that's a vindication of James Hansen's work.
Thanks, Paul. Let me ask both of you, I'm sure there are many of our viewers who are watching this and say it's already hard enough to sort of keep up with atmospheric greenhouse gas concentrations. Carbon dioxide is 423 or 424. It used to be 280. Temperature increases over pre-industrial are 1.4 or 1.5. Maybe they're going to go to 1.7. What is the significance of this additional metric, if you will? What should our viewers know about does it change the picture at all in terms of how dire things are? Does it change the policies that we need to follow and put into place that we've yet to do for 30 years or so? In other words, what is the practical significance of this very alarming number, but within the larger sort of world of climate change? Either Peter or Paul.
Well, it's an excellent question, but I do think you have to put it all together. We need to look at Earth energy imbalance. We need to look at global warming, obviously. Yes, we need to look at ocean heat, but we also need to look at atmospheric greenhouse gas concentrations. And probably the most important statement in this report, and there are many important statements, is that, as Herb, you indicated, that atmospheric CO2 is now 424 parts per million. You really only have to understand atmospheric CO2 to understand the state of the dire emergency that we're in. Atmospheric CO2 is increasing at an exponential rate. And as the WMO reports, the last increase of 2024 was over 3 ppm, 3 parts per million in a year, which was by far the highest increase that we had ever seen in atmospheric CO2. So, yeah, Earth energy imbalance restates in no uncertain terms that the planet is being wrecked essentially by the fossil fuel industry, supported by our governments. So
Yeah.
that's what all this means. It means the planet's being wrecked.
Well, it's hard to come up with anything more succinct and to the point than the comments in the few words you just said. Before we go into our second round of this, Paul, do you have any brief comments with regard to the question of, I might, if one were cynical, to say, so what? We already know things are bad. What does this additional information from the Earth energy imbalance tell us?
I think what it tells us is the urgency for trying to restore a healthy planet is much, much higher. Each of
Mm.
these reports is more and more dire. If finally governments stand up, engineers around the world with governments and scientists say, okay, so can we do anything about this? And at least look seriously into ways to remove carbon from the atmosphere to restore levels that are safe for humanity. Humanity's never really lived for an extended period of time above 300 parts per million. So that's one thing. And the other thing is, do we need to do other things like try to simulate volcanoes and things to lower global temperatures to buy us time to remove CO2 and methane and other things? So yeah, I mean, we're going down the crapper, basically. So, when enough people recognize how deep we are into going down the crapper, maybe they'll seriously take some of these other things into consideration. Not giving the fossil fuel industry, a free pass, but trying to protect some semblance of our climate for our kids and grandkids, because the way we're
Yeah.
going,
Yeah.
there's no future for them.
Well, we've heard about going down the crapper and that the climate and the world is being wrecked. And I won't disagree with either of those characterizations, depending upon how informal one wants to be. And this is no time for formality, that's for sure. This is time for straight talk. And I think one of the things that I appreciate here, and I think our viewers do, is that both Peter and Paul are not shy in straight talk. And with that, let me turn it back to Peter for some more straight talk as we go to the second portion of our program.
One most important aspect of the science that really isn't out there, and it shocked me when I first came across it, was that if you look up NOAA and ocean temperature, you will find that at the end of their very excellent short report on what ocean temperature is all about, they say this: eventually, the ocean heat will return heat to the atmosphere, and this will further increase the rate of global warming. So, the scientists have long acknowledged, that the ocean has sort of been not given the importance that it needs to be given. So, yeah, we're an ocean planet, but we, as Paul mentioned, the ocean currents are being massively, massively disturbed by this unbelievable amount of heat that's being added to the oceans. I think that the last year was another record for ocean heat, and it has just been accelerating steadily. There's been no up and down business like global warming with ocean heat. The increase of heat in the last year was the same as 200 times all of the energy used by our energy requirements in the world. So we're sitting on what is nothing short of an explosive situation. And we have to intervene, and we have to intervene aggressively. I agree. I've said for years, we have to develop a rapid capacity for both removing carbon dioxide from the atmosphere and for cooling the planet effective and safely. That is the moonshot. And yet our world is so crazy that we're shooting men up into the moon again, right? So really what this demands, if you ask, what does this massive rate of increase of Earth's energy imbalance demand? It demands this. It demands that the whole world devote and commit all of our resources, all of our amazing human resources, right, to solving the climate emergency issue. That's what it means.
Mm.
All of this money which is being spent killing people all over the world, and all of that technology has to be transferred to ensuring that there is a future, as Paul mentioned quite properly, for our children and our grandchildren. So that is our absolute duty. And I thank all of our panel here for repeating that this has to happen.
Thank you, Peter. What you're saying strikes me as We've had this, what might be seen as a kind of mortgage debt, that all that heat that's going into the ocean is, one of you may mention, it's kind of a time bomb. It's a debt that will have to be repaid. And you might say it's kind of like a subprime mortgage, and that it's going to explode in the worst possible way. But look what happened when we had the Great Recession 15 or so years ago, or 20 years ago now, close to it. The world mobilized, perhaps imperfectly, to spend trillions of dollars out of thin air. I mean, they put keystrokes on computers, and all of a sudden the banks had billions of dollars to lend. And that was a kind of phony crisis. I don't mean to suggest people weren't harmed, but it was basically a crisis of finance, of how we exchange things, not a real physical crisis. And yet, with a physical crisis, we're doing nothing. With that, let me turn it back to Paul.
The last few decades, the average, the over 90% of energy warming on the planet, warming the oceans, and mostly the surface layers of the oceans, the average amount of heating has been about something like 11 zetajoules. You'll have to look up zetajoule. It's a huge number, far exceeding 1 zetajoule, far exceeding the overall human energy usage on the planet. But that's the average over a few decades. In 2025, the number was 23 zetajoules, which is double the average. So as bad as it is, it's accelerating at extremely fast rates. I mean, that's the key thing. The ocean, it's not going to be a buffer for much longer. As Peter mentioned, the heat has to come out at some point. So let's look at a little case study of the Mediterranean Sea. The water temperatures were extremely high in the Mediterranean Ocean. A lot of that heat did come out in 2024, and what it did is it created tremendous amounts of water vapor carrying up the latent heat. That water vapor made its way over to Valencia, Spain. It caused these massive thunderstorms. The internal convective uplift of these storms was increased, 10, 20%. So the energy of the storm, the CAPE, convective available potential energy, was huge. If you're a storm chaser, tornado chaser, you really pay attention to CAPE. It's sort of the energy of the atmosphere that can power the storm. The net result was that they got basically a year of rainfall in one day over Valencia, Spain, and hundreds of people died. Huge areas got flooded out. The rainfall rate was 20% higher than it would normally be. And that was far in exceeding the physics of what we understand from the Clausius-Clapeyron equation, which states that for every 1 degree Celsius rise of temperature, you get 7% more rainfall. Well, they had 20% more rainfall just because of the conditions that were set up. Basically, imagine a fire hose stretching from over the Mediterranean Sea to Valencia, Spain, and all that water being deposited in a very short period of time. So this is what we have sort of to look forward to. When the main ocean heating starts getting transferred to the atmosphere, then you can imagine how bad that is going to be, because 90% of the heating is in the oceans, only 1% of the heating is directly heating the atmosphere, 1 or 2%. So when that ocean heat finally does make it into the atmosphere, it's going to be catastrophic for many, many people, many regions.
Yes, another sobering perspective. Thanks, Paul. And you sort of raised the question about zeta joules, and so I did some quick math, not in my head certainly, on my phone, and getting back to what I said at the beginning of the program about the number of Hiroshima bombs exploding every second, equivalent to the Earth energy imbalance. Apparently, one Hiroshima atomic bomb releases approximately 0.00006 zetajoules. In other words, what we're talking about in the way of 10 or 20 or 30 zetajoules is infinitely greater than the power of the Hiroshima bomb by a factor of, thousands and thousands. And I think that's one of the challenges that I'm going
Mhm.
to ask Peter and Paul in our last couple of minutes. How do even policymakers, forget about everyday people, begin to comprehend the scale of the damage that's being done, and the scale of the recovery that's required. This is unlike cleaning up even a major river or cleaning up a power plant. We're talking about unimaginable levels of heat and unimaginable levels of human effort to reverse this challenge. How do we convey that to the people that make decisions, or is it even worth trying? Peter, Paul, your thoughts?
Just one physics fact, try running and you can run, but try running through water, it's very difficult. Like the density of water is so much higher than that of air. The heat capacity of water is enormous. So the amount of energy required to heat, say, 1 cubic meter of water compared to 1 cubic meter of air, we're talking about 3 to 4,000 times more energy to heat it up 1 degree Celsius. So it takes an awful lot of energy, and this is why that energy, that 90% going to the oceans is kind of not seen by us landlubbers until we see the effects of that warm water vapor into the atmosphere and storms and so on. So it's sort of unfortunate. I mean, most of the heating goes into the oceans. We don't live in the oceans, we live on the land. So we kind of ignore it until it hits us through some indirect effects, which is really doing at the moment in a big way, especially Valencia. That's just one example of what happens when all that heat can suddenly quickly come out of the water into
Yeah.
the atmosphere.
Peter, your thoughts?
Well, the situation tragically and deplorably is that our governments and policymakers do not want to understand the climate change emergency. They are informed by the IPCC in no uncertain terms what the situation is, but they're not committed to the future. They're not committed to humanity. They're not committed to our children and grandchildren. They're not committed to the natural world. They are committed to the fossil fuel industry. That's the stark situation that we're in. I keep on saying how much these subsidies are, and, $7.6 trillion a year now, every single year. So there's this phrase, pushing political will or whatever it is. The people have to compel their governments. The people have to rise up. They have to compel their governments to pay attention to the science and to act on what the science is telling them to do, which is immediate action, as all three of us have totally agreed on, of committing everything to having a future. The only way to do that is to, yeah, as Herb, you mentioned, we have to tell the science in no uncertain terms. Scientists do tend to hold back on the seriousness and the terrible extent of what's going to happen. And we're backing off. We're backing off that nowadays. We have to push harder. We have to tell what I call the terrible truth at every opportunity.
Yeah.
And we do have to lobby our governments. They're being lobbied by the fossil fuel industry. So we should be doing the same thing.
Thank you, Peter.
Yeah, Peter's describing Western Hemisphere governments who are mostly made up of lawyers. In fact, you could argue the US is a lawyerly society. I would contrast that with China, that's an engineering state. If you look at the composition of the Chinese government, it's mostly engineers and STEM people, scientists and stuff. So maybe we should be translating our videos into Chinese, and also that's 1.4 billion people, and also into some Indian languages, which is also 1.4 billion people. If we push our videos and ideas to do something to the Chinese people, then I think we have much better chance of having any breakthrough and hope, because these people are trained in science and engineering, and our governments don't want to hear the science. They're not scientists. They don't understand it. They don't want to understand it. They're interested in bureaucracy and suing people and so on. That's just the reality of Western governments versus some other countries.
Well, that's an interesting perspective, Paul. And let me just say as we wrap up, before we get to the climate three, that we have typically anywhere from 2,000 to upwards of 10,000 people who watch each of our programs. Let me put a challenge to our viewers. If 10% of you, 1 out of 10, after you watch this program, send an email, and you could probably get an address in 30 seconds of your local representative or your national leader, wherever in the world you are. And we have people from all over the world. That would make a difference because I've worked in government. Not that that makes me an expert, but I've talked to lots of people. And most elected officials, except on very few issues, don't hear from the public. And even a few hundred or even a few dozen strongly worded messages may begin to get through. And I'm not being naive here. I don't think it's going to lead to a revolution, that CEF will be at the vanguard of the revolution. But nonetheless, you wouldn't be watching us if you weren't concerned about these issues. You come back week after week, you listen to Peter and Paul very articulately and passionately talk about the mess we're in, the catastrophic mess we're in. And it's up to you. It's up to you, who are our viewers, to take the next step. And leave us your comments, leave us your thoughts. If you have reached out, tell us why, and what happened as a result. And so, with that, I want to thank Peter and Paul, as always, for a very important conversation. And with that, I want to turn to what we call the Climate three of the most important out of the many climate stories from the past week or so. And first is that we've talked earlier today about the IPCC, and I read something that surprised me, shocked me a little bit. Headline saying that France condemns an effort to delay the major IPCC climate report. Every 5 to 7 years, a major report comes out. We're coming into our seventh round of those reports. They're due out in 28 or 2029. And apparently, India, and we also spoke of India just a few minutes ago, India and Saudi Arabia have come together to lobby to delay the major IPCC report from 2028 to 2029. And here we are in a climate emergency where the IPCC reports are the most authoritative. And yet, two countries, two very significant countries, want to delay it. And why did they want to delay it? Because apparently they're in the running to host the COP that year in 2028, Saudi Arabia and or India, and they'd rather not have the inconvenience of a major report. I suspect this is particularly true for Saudi Arabia, talking about the need for action just before the COP. Sorry not to sound a little cynical, but it's truly a shocking but all too typical indication of where we are internationally. That's climate story number one. Climate story number two, maybe a little more positive news coming out of this horrendous war we're in, and that is that a major industrial group in Hanoi, in Vietnam, has told Vietnam's government it wants to ditch a plan to build the country's largest liquid natural gas-fired power plant and embark on a renewable energy project instead, as the Iran war has boosted the risk of the fuel becoming too expensive, a document showed that came out today. And we can only hope that that rational decision that's being made by a major company in Vietnam is made by companies and governments all over the world. And at least maybe something good will come out of this disastrous war that otherwise is so harmful to so many aspects of the climate and everything else. The third story, and this is just a possibility, but researchers in Japan have developed a new material that allows solar cells to generate an amount of energy from sunlight that was previously thought impossible. The discovery made by a team at Kyushu University involves a special, quote, spin flip emitter that can harvest energy from the sun that is typically lost as heat. The breakthrough overcomes the long-standing limit of conventional solar cells and allows an energy efficiency of up to 130%, which would revolutionize solar cells. So I think that the point about that is not whether this will happen. We certainly hope it does. But the difference between wind and solar is they will continue to get cheaper as technology gets better, while oil and gas get more expensive as you have to dig deeper to get it out of the ground. One more of the many, many reasons why renewables, while not the full answer, are a critical part of the answer. And with that, I want to thank again Peter and Paul, and I want to say to all of the viewers, please leave us your comments, your questions, and as always, we thank you for attending today, and we look forward to seeing you next week. Thanks so much. Goodbye.